Good day and God bless everyone. So welcome to Torio Rapido channel. In this video, I will be discussing finding the inverse of a function. How can we say that two functions are inverse functions? So functions, let's say f of x and g of x are said to be inverse functions if their composition rule is equal to x. That is, f of g of x must be equal x and g of f of x equals x. If these two conditions are satisfied by the functions f of x and g of x, then they are said to be inverse functions. So how do we find the inverse of a given function? So before we discuss that, so let me give you first an example of functions that are inverse function. Consider the function f of x equals 3x plus 1 all over 5, and the function 5x minus 1 all over 3. So let us verify whether these two functions are inverse functions. First, verify whether f of g of x is equal to x. So we will be verifying whether this composite function is equal to x. So f of g of x equals, so we have here f, so we'll be using the function f of x, and the variable of that function will be replaced by g of x. So we have here 3 times g of x, which is 5x minus 1 all over 3, and then we have here plus 1 all over 5. So we're going to simplify this expression, so 3 can be cancelled out, so leaving us 5x minus 1 plus 1 all over 5. So to continue, negative 1 plus 1, so this is equal to 0. So we have now 5x all over 5, and again 5 can be cancelled out, leaving us only x. So here we have our first condition, f of g of x equals x. Let us also verify the second condition, which is g of f of x must also be equal to x. So let us again verify this. So again, g of f of x means that we're going to use the function g of x, and its variable will be replaced by f of x. So we have this is equal to 5 times. So f of x is 3x plus 1 all over 5. So we have 3x plus 1 all over 5. And then we have minus 1 all over 3. Okay. Yes, that is all over 3. So again, simplifying this expression, so here we can cancel out 5. That will leave us 3x plus 1 minus 1 all over 3. And 1 minus 1 is equal to 0. So now we have 3x divided by 3. And 3x divided by 3 is simply x. That is by cancelling 3. So here we have verified that g of f of x is equal to x. So we can conclude that f of x and g of x are inverse functions. So again, the two conditions for the composition rule, okay, must be equal to x for us to say that the functions are inverse function. But how do we find inverse of a given function? So just follow the following steps. So these are the steps in finding the inverse of a given function. Step 1, so we have to replace either f of x or g of x by 1. So this functional notation f of x or g of x will be replaced by y. That is step 1. Step 2, interchange x and y. Meaning, in the function, x will be replaced by y and y will be replaced by x. Step 3, solve for the new y. Okay. And step 4, so after we solve the equation for the new y, so the result will be already the inverse of the given function. So step 4 will be rewriting the proper way of writing the inverse function. So to denote the inverse of f of x, so use either, so depending on the given function, so use either f prime of x or g prime of x to denote the inverse. So these are the four simple steps in finding the inverse of a given function. So let us apply these steps in finding the inverse function of the following. So let's say we have here, so find the inverse of the following functions. Let us say, number one, we have f of x equals 7x minus 1. So this will be our solution. So from the given steps, the first thing we must do is to replace the functional notation by y. So we have here y equals 7x minus 1. Step 2, interchange x and y. It means that y will be replaced by x and x will be replaced by y. So we'll have x equals 7y minus 1. And the third step is we will be solving the equation for the new y. So this is the new y. So solving this equation for the new y, so you transpose derivative 1. So we have x plus 1 equals 7y. And then divide both sides by 7. So y equals x plus 1 all over 7. And this is already the inverse of 7x minus 1. But to appropriately denote the inverse of f of x, so we use prime sign. So f prime of x, which denotes the inverse of f of x, is now equal to x plus 1 all over 7. So how are you sure that this is the inverse of 7x minus 1? So you verify. So again, verify that f of g of x equals x and g of f of x also equals x. So let the original given function be our f of x, and then the inverse be g of x. So here, by verifying first f of g of x, so this will be equal to, so again we'll be using the function f, and its variable will be replaced by g of x. So we have here 7 times g of x, which is the obtained inverse function, is x plus 1 all over 7. We have minus 1. So this is 7x minus 1, and x is replaced by g of x. So simplifying that, or this expression, so we can cancel out 7. So we'll have x plus 1 minus 1, and 1 minus 1 is equal to 0, meaning this is equal to x. So our first condition is verified. Okay, so second condition, so verify also g of f of x. whether this is really equal to x. So is that equal to x? So again, we'll be using the function g, and its variable will be replaced by f of x. So our g is our inverse, which is x, so that will be replaced by 7x minus 1. So we have 7x minus 1, then we have plus 1. Okay, this is actually x plus 1, but x is replaced by f of x, and that is all over 7. So again, we simplify this. So we remove the parentheses, so we have 7x minus 1 plus 1 all over 7. And negative 1 plus 1 is equal to 0. So we have here 7x over 7, and again cancel out 7. So our final answer is x. So again, the composition rule for the two given functions are each equal to x. That is why we can say that the inverse of 7x minus 1 is x plus 1 all over 7. Okay, so let us have another example. So example number 2. So what is the inverse of the function 2x minus 1 over 3x plus 2? So again, just perform the steps in finding the inverse of this function. So step 1, replace g of x by y. So we have y equals 2x minus 1 all over 3x plus 2. Step 2, interchange x and y. So make y x and make x y. So we have 2y minus 1 all over 3y plus 2. And then solve for the new y. So we'll just cross multiply this. So by cross multiplication, we have x times 3y. So that would be 3xy. And x times 2 is plus 2x equals 2y minus 1. So here we are solving for y. So let us isolate the terms involving y at the left side. So that is by applying transposition. So u transpose 2y to the left side and 2x to the right side. So in doing so, we have 3xy minus 2y equals negative 2x minus 1. So for us to solve for y here, we will be applying common monomial factoring, since y is a common factor. So we have here 3xy divided by y is 3x, minus 2y divided by y is 2, equals negative 2x minus 1. And we just divide both sides of the equation by 3x minus 2 by 3x minus 2. So this can be cancelled out, leaving us only y equals negative 2x minus 1 all over 3x minus 2. So this equation is now the inverse of g of x. And to properly denote the inverse of g of x, so we'll be using the prime sign. So the inverse of g of x is g prime of x, which is equal to negative 2x minus 1 all over 3x minus 2. So this is our now final answer. So you may still verify this. So verify the condition. So let us verify the condition. So let us first have f of x, or let's simply use g of x and g prime of x. So verify g of g prime of x. So this should be equal to x, and g prime of g of x should also be equal to x. So let us verify first this one. So here we'll be using the original function g of x, and its variable will be replaced by g prime of x. So from our example, g of x 2x minus 1, so that would be 2, and then variable will be replaced by g prime of x, which is negative 2x minus 1, negative 2x minus 1 all over 3x minus 2, 3x minus 2, and then that would be minus 1 all over, we have 3 x, and again x will be replaced by negative 2x minus 1 all over 3x minus 2, and then we have plus 2. Okay, it's plus 2. So this expression, when simplified, must be equal to x, since g and g prime of x are inverse functions. So let us simplify this. So here we have 2 times this one will be negative 4x minus 2, okay, all over 3x minus 2 minus 1 all over, multiply this by 3, so we have negative 6x minus 3 all over 3x minus 2, then we have plus 2. So let us combine the terms in the numerator and of course in the denominator. So we have a shortcut here, and that is by cross multiplication. You cross multiply this, and the denominator is equal to the product of the two denominators. So let's apply that one. So we have 1 times negative 4x minus 2 is negative 4x minus 2, and then minus, so ito naman, so we have 3x minus 2 times 1 is 3x minus 2, and then this is all over 3x minus 2. So since this is division, so let us proceed to multiplication, but you have to get the reciprocal of this. So again, this is over 1. So by cross multiplication, so we have this one. So this is in the or this is the denominator. So since we will be proceeding to multiplication, so this will become the numerator of the reciprocal. So we have 3x minus 2. And this will be all over. Okay, so the answer here, so 1 times negative 6x minus 3 is negative 6x minus 3. And then we have plus, we have this, so 2 times 3x minus 2. So from here, we can see that we can cancel out 3x minus 2. And then simplify this. So negative 4x minus 2, so we write negative 4x minus 2. Then remove the parenthesis here. So that would be minus 3x and then plus 2. So why plus 2? Because we have here negative times negative 2. And then this is all over. Okay, this one. So we have negative 6x minus 3. We have negative 6x minus 3. And then this will be multiplied by 2. So 2 times 3x is plus 6x, and 2 times negative 2, this one, so 2 times 3x is 6x, 2 times negative 2 is negative 4. So we simplify this. Negative 4x minus 3x is negative 7x, and negative 2 plus 2 is equal to 0. And this is all over. So here we have negative 6x plus 6x is equal to 0. Negative 3 minus 4, that is equal to negative 7. And here we can cancel out negative 7. So leaving us only x. So the first condition is verified, that g of g prime of x is equal to x. So let us have the second one. So let us verify g prime of g of x. So let us see whether it is really equal to x. Again, g prime of x is negative 2x minus 1. So let me rewrite g prime of x. So here we'll be verifying g prime of g of x, whether this equals to x. So g prime of x is negative 2x minus 1, negative 2x, so x will be replaced by g of x, which is 2x minus 1 over 3x plus 2. So 2x minus 1 over 3x plus 2. And then we have minus 1 all over. Again, g prime of x is negative 2x minus 1 all over 3x. So that 3x, so x will be replaced again by g of x, which is 2x minus 1 all over 3x plus 2. And finally we have minus 2 here, minus 2. And then, like what we did in the first verification, so let us simplify this one. Let us write the simplification here. So negative 2 times 2x minus 1 is negative 4x. Negative 2 times negative 1 is plus 2 all over 3x plus 2 and then minus 1 all over. So 3 times 2x is 6x. 3 times negative 1 is negative 3 all over 3x plus 2, and we have minus 2. So again, let us combine this numerator and this denominator. So we have, by cross multiplication again, this is over 1. So 1 times this is negative 4x plus 2. And 3x plus 2 times negative 1 is minus 3x plus 2. This all over 3x plus 2 times 1, that is 3x plus 2. And then all over our denominator, so do the same thing, cross multiply. So 1 times 6x minus 3 is 6x minus 3. And then minus 3x plus 2 times negative 2 is minus 2 times 3x plus 2. And then all over 3x plus 2 times 1 is 3x plus 2. So from here we can or we may cancel 3x plus 2. So that will have, so let us simplify this. Negative 4x plus 2, remove the parentheses, it will be minus 3x minus 2 all over here of 6x minus 3, and again multiply negative 2 to 3x plus 2, so we have minus 6x, and then we have minus 4. If we're going to simplify this, so we have here negative 4x minus 3x, that is equal to negative 7x, and positive 2 minus 2, so that is 0. In the denominator we have 6x minus 6x is 0, and negative 3 minus 4 is negative 7. So we can cancel out negative 7 here, and leaving us only what? So we have here x. So again, the second condition is verified. So since both composition rule is equal to x, we can say that the inverse that we obtain is correct. That the inverse of g of x is really equal to negative 2x minus 1 all over 3x minus 2. That is our example number 2. So let us have example number 3. So in the succeeding examples, so we will not verify anymore. So let's say we have number 3, h of x, say this is equal to square root of 3x minus 7. So let us find the inverse of this function. Let us perform the steps. Step 1, so replace this functional notation by y. So we have y equals square root of 3x minus 7. Step 2, interchange x and y. Y will become x, and x will become y. Step 3, solve for the new y. So since the new y here is under this square root sign, so we have to remove this square root sign by simply squaring the equation. So we have here x squared. This x squared equals the square root of 3y minus 7 square. Again, this square root sign and square can be cancelled out. So that will have 3y minus 7. Transpose negative 7, so we have x squared plus 7 equals 3y. Divide both sides by 3. We will have y equals x squared plus 7 all over 3. So this is already the inverse of h of x. But to properly denote the inverse of h of x, so we write h prime of x equals x squared plus 7 all over 3. So this is now the inverse of h of x. Another example. Supposing we have sample number 4. Let's say we have f of x equals 5 to the 3x. So here we have an exponential function. So what do you think is the inverse of this exponential function? So again, let us follow the steps. Step 1, replace this by y. So we have y equals 5 to the 3x. Step 2, make this x and make this y. So 5 to the 3y. So here we have x equals 5 raised to 3y. So this is 3y, this is 3, not 5. So for us to solve for y in this equation, so we'll be applying logarithm. So get the logarithm of both sides. So you may use natural logarithm or ln, or common logarithm, or simply log. So let us use natural logarithm. So we have here natural logarithm of x, or ln x, equals natural logarithm of 5 raised to 3y. And we have that property in logarithm that exponent can be rewritten as coefficient of the logarithm. So we can bring this down here, and that is valid by logarithm of a power. So we have now ln x equals 3y ln 5. So to solve for y, so we can simply divide both sides of this equation by 3. ln 5, 3 ln 5. So we can cancel 3 and ln 5, leaving us only y. So we have now y equals ln x over 3 ln 5. And this is now the inverse of that exponential function. So our final answer will be f prime of x equals ln x over 3 ln 5. Let us try to verify one of the two conditions for this example. So let us see whether the composition rule is really equal to x. Let us verify f of f prime of x and see to it whether this is really equal to x. So what is f of f prime of x? So we have five raised to 3 times. So it is our original function. So this x will be replaced by this one, which is the inverse. That is ln x over 3 ln 5. So here we can cancel out 5. So we will have now 5 raised to ln x over ln 5. It is something equal to x. So let us see. Take note that this expression, remember in our change of base formula, so by change of base formula, we can rewrite this as ln of x to the base 5. So this is by change of base formula. So by doing so, we have now 5 raised to ln 5 x, or 5 raised to ln of x to the base 5. And again, we have that property in logarithm that if you're given an exponential form, okay, whose exponent has a base same as the base of the original exponential form, the value of the whole exponential expression is simply equal to this number. In this case, that is equal to x. And actually, to avoid the confusion here, so since here we have a double base, so ln is base e, then we have another base 5 here. So to avoid that confusion, instead of using ln here, you can use a common logarithm. So this one, this expression is the same as logarithm of x over 3 logarithm of 5. And if we will be using this one, so take note, so this expression, the value of this expression is the same as the value of this one. But let us try to use this. for you to really understand that this expression is really equal to x. So again, let us have another page for this one. So let's have 5 raised to 3 and times. So again, instead of using ln, so let's use log or homologarithm. So we have logarithm of x over 3 logarithm of 5. So from here again, we can cancel out 3. So we'll have here 5 raised to logarithm of x over logarithm of 5. And again, by change of base formula, this can be rewritten as this one, as logarithm of x to the base 5. So using that, we'll now have 5 raised to logarithm of x to the base 5. So again, if we have this exponential expression, just look if this base is the same as the base of the logarithm. And if they are equal, then the value of this full expression is simply this number. So we have now, so this expression is equal to x. So how to verify whether this is really equal to x? So let us have 5 raised to logarithm of x to the base 5. So we have said that this is equal to x. So let us see whether it is really equal to x. So how? Let's try to, since this is exponential, so let's try to rewrite this in logarithmic form. That is by taking the logarithm of this. So logarithm of x, so logarithm of this, and the base is what? So the base is 5 here. This is equal to the exponent. So the exponent of 5 here is logarithm of x to the base 5. And we see that these two expressions are equal. And that proves that this exponential expression is really equal to x. And we have verified that the composition rule for this one is equal to x. And that suggests that the inverse of 5 to the 3x is either ln x all over 3 ln 5 or logarithm of x all over 3 logarithm of 5. So let's have another example, number 5. This time, let us have a logarithm. So let us say we have g of x equals natural logarithm of 2x plus 1. So what is the inverse of this function? So again, solution. So replace g of x by y. So we have y equals natural logarithm or ln of 2x plus 1. Second step, interchange x and y. So y will become x equals ln of this x will become y. So ln of 2y plus 1. And in solving for y here, so we need to transform this logarithm or this logarithmic expression into exponential form. So since this is natural logarithm, so we know that ln is the same as logarithm to the base e. So the base here is e. So to convert this in exponential form, so we have this base is always raised to the other side. So base is e, so we have e. So what is the other side? So we have x, so we have e to the x equals to this expression, 2y plus 1. We transpose 1, so we have e to the x minus 1 equals 2y. Divide both sides by 2, so we have y equals e to the x minus 1 all over 2. And again, this is now the inverse of ln of 2x plus 1. So to denote the inverse of g of x, so we have g prime of x equals e to the x minus 1 all over 2. So this is now our final answer. So let us again verify one of the conditions. So one of the composition rule must be equal to x. Let us try to verify g of g prime of x, whether this is really equal to x. So g of x is ln of this. So we have this equals ln of 2x. So that x will be replaced by the inverse, which is e to the x minus 1 all over 2. So we have, let's erase this one. And let's use the base. So 2x, so that will be 2 times the inverse e to the x minus 1 all over 2. And then plus 1. So this is 2x plus 1. So let us simplify this expression. We can cancel out 2 here. So we'll have natural logarithm of. So we have here e to the x minus 1 plus 1. And take note that negative 1 plus 1 is equal to 0. So we'll have only ln of e to the x. So again, this is one of the property of logarithm. So if we will apply logarithm of a power, so this power or this exponent x can be brought down here. That is by logarithm of a power. So we'll have here x ln e. And take note again that this ln is logarithm to the base e. So this is x logarithm of e to the base e. And again, this is one of the properties of logarithm, which states that when the number is the same as the base of the logarithm, then the value of the logarithm is equal to 1. Meaning, logarithm of e to the base c equals 1, because when we rewrite this in exponential form, so this is e to the first equals e. So base is raised to the other side, which is 1. So e to the first is equal to e. So this one, or simply this expression, is equal to 1. And x times 1 is equal to x. And again, one of the two conditions is verified. That is the one of the composition rule is equal to x. So we can say that the inverse of ln of 2x plus 1 is really equal to e to the x minus 1 all over 2. That's how to find the inverse of a given function. I hope you learn a lot again from my discussion. So wait for my other videos in mathematics. Thank you for watching.